So I decide that I need to fix this format output. So I'm going to basically when I say print total fee, before I print the total fee, I will switch over to fixed format because this is a double, and also say set precision and modify the precision to use like 2 decimal points after the floating point, two significant digits over there. And to be able to use these manipulators, I need another header, which is right here, which is going to be I think it's iomanip. Yeah, iomanip. Let me build that. Okay, and just make sure my logs look good. Right, so now I can again try running it and say, okay, run it. Yeah, so now see the formatting looks much better. Okay, good. So just wanted to fix that. So I have written quite a bit of code in this application, okay? So obviously I'm posting the sample online and you can download and see what I have done so far. Of course, I programmed everything from scratch, so if you watch it on YouTube, you can see the progression that I'm making. But at this point, this is what I would like to do. I would like to say that my next iteration through this project is that I would like to say what functions actually are modifiers of my objects and what functions are simply accessors, read-only style functions. Because remember we said that any time we can specify that something is immutable, it's really good news for the compiler and makes our class design and application structure much stronger. For example, print. Should it be a constant declared as constant function? Absolutely yes. We want to indicate to the compiler that print function does not attempt to make any changes in this set of objects. Now, computation of fees at the pet level, does it change anything in the pet object? No. So this should be const, right? Does compute discount? Same thing. It should be a constant function. So basically you need to examine. Now constructor of course modifies the object because it initializes it, so it cannot be const and should not be used as const. But these functions, print, compute, fee and discounts, should be declared const. Pet owner, let's see, add a pet, of course it modifies the content inside the vector, so this cannot be const. Print of course should be const, right? Compute fee definitely doesn't change anything and should not change anything, so we make them const quite easily. Then at the pet license, calculate fee actually does update the total, so it's not constant function, but print should be, right? Print doesn't change anything, so we say const. And compute fee, likewise, at this level can be declared const. So this is a very typical and normal approach to say whatever doesn't make changes to our classes should be declared as const in every single class. So unfortunately, it's a bit of a hassle because now I need to go to my pet license and actually make updates in this file as well, in my implementation file, right? So add, not a const. Print should be const, and it requires a constant at the signature of the function. We need to be able to add the same keyword at the end of the function parameters. We add const, and this is a placeholder for that, right? So const here indicates that the function itself is const and promises not to make any changes. By the way, I just spotted as something else. I think at the pet owner is senior citizen also should be a const, right? It doesn't change anything. It only tells whether this owner is a senior citizen. All right, good. So moving on, senior citizen right here, const, right? This should be a const function. Print, always const. Sounds good. Constructor, not a const. Calculate fee, changes the fee, not a const. Print is const. Okay, compute fee over here. It does return a value, but never changes anything inside the object itself. So we decided that all of these functions are going to be const in our application. So we're going to make these changes and see what's going to happen to this entire program when we try building it, right? So I think I'm done making these changes for, I have to do this in both places, in the header file and in the implementation file. I'm going to press Control-Shift-S to save all of my changes and now say build again, right? Just say build. Okay, so let's take a look at the log. Apparently there were problems which I need to view. And the problem here says that so basically it reads here, invalid initialization of reference of type pet, right, reference to pet, from expression of type const pet. Why? Because this specific function print inside pet owner promises not to change anything, and yet trying to access pets in such a manner that this pet reference is non-const. So, so for the safety's sake, we need to do this, right? We need to say, well, no, that's fine, because at this level, we promise that this reference to every single pet, which we will use in this for each loop, for each element inside the collection of pets, the reference that we're going to be using is also going to be const, and therefore it's safe to use const reference and call print. Okay, so we need to add this const to calm down the compiler and say you don't have to be stressing over it. Everything that we do here is a read-only manner and doesn't change anything. So let's just again save everything and build it again. And this type says compute fee. I missed the const over here, right? So it says doesn't match the original declaration, right? So just miss this, that's fine. Build again. So the next thing is here, compute discounts again. I somehow missed these const qualifiers for my function. Build again. And this time everything builds fine, right? So this was an iteration of changes that I thought would be very helpful, and normally this is very, very important to keep track of everything that should be const. All of these additions here make a much stronger design and much better and much more optimized use of memory. All right. After all, if you think about object-oriented programming, what it does, it really manages the memory of objects, because ultimately there are only two building blocks in software: variables in memory and functions. And all of this object-oriented technology really manages how compiler allocates memory, how variables can be accessed. And if any time we can indicate to the compiler that this part of our application does not attempt to change anything, our obligation, our responsibility is to tell the compiler that that's our intent. We promise not to make it constant. And then also, if we accidentally, unintentionally attempt to change something, compiler will give an error and say, you just promised that this specific function, say print, you said it's not going to change anything, but all of a sudden you tried to change some memory. So this is yet another level of safety. From all angles, this is very important type of improvement in structuring our classes. And you can see it doesn't take much effort to actually do this. Just that's a review that is important.